So I guess I'm here in a different capacity. Normally I'm economics partners and wear an evaluation hat. Now I'm here as a software person. So crowdREASON is the name of my company. At crowdREASON, we use technology to build software systems, specifically around property tax is one of our main focuses. So I'll talk a little bit about what we're doing within those technologies and kind of bring some of this AI stuff to kind of the real world, which is what we deal with every day. So I found an interesting comment that came out of McKinsey's recent report, basically saying that half of all work activities globally, think about all work activities globally, that's a big world, have the technical potential to be automated by adapting currently demonstrated technology. So we're not up this doubled exponential curve like Larry was talking about and projecting what will happen whenever that endpoint is, but current technologies can automate 50% of all work today. Anybody believe that? Nobody believes it. Interesting, okay. Why not? Why tomorrow can't we completely automate 50% of the work out there? Anybody have any guesses as to why?
Subjectivity of things.
Okay, subjectivity of things. They're too complex and we can't really kind of break those down into a logical framework, maybe? Any other thoughts?
Workers won't love it.
That's a good one, yeah. Change management. Change management is standing in the way of much of this. What other reasons why we can't automate 50% tomorrow? Ethics, okay, good one. Maybe we don't believe in certain results that come from a computer, or maybe we don't think it's ethical to replace a person with a computer, right? So there's kind of different takes on that. Any other thoughts? Cost, that's a good one. It's expensive to develop these technologies and create something that works. But interesting enough that the portion of work actually displaced by 2030, and they're really talking about now in a different framework, about by 2030, there's only really 15% of the work that's really going to be displaced. And so, well, why is that? Well, it's kind of what we talked about right here, is that the technical, economic, and social factors that affect adoption, right? So the technical things, it's expensive. The social factors, maybe it's not ethical, and adoption as in change management, right? No, don't do that to me. Claire.
15%, that's from now to 2030?
In 2030, by 15% of the current work population will be displaced.
So, do you have an estimate of what workplace has been displaced since 2000 by automation?
Sure. I think really what happens, what is the definition of displacement, right? Is it like I'm out of work and I'm never going to work again? Or is it I don't do the things I used to do, right? So I think that's effectively what's happening, is that people are doing different things as opposed to doing the same old work that they used to do because of automation, right? So how many farmers were there in 50 years ago, right? Most of the population was farmers, where today it's a mere fraction. Why is that? Because of automation. But does that mean that we were in a social economic despair because we don't have all the farmers that we need? So
you're saying if 15% is displaced by 2030, there will be other, I mean, really displaced, really that much less employment?
Yes, I think so. Yeah, I think that's what they're saying. Then you get into kind of how do you manage that, and how do you kind of make sure that people are able to carry on, right? So there's a whole discussion around that, a living wage, and how do you kind of fund that. This does change dependent upon whether you're a technologically advanced economy or not. And so the more advanced economies will have more displacement, interesting enough, which means us, right? We'll have more than 15%. 15% is kind of a midpoint. So something to be concerned about. 2030 will, I think I'll still be working by then. But so how does that really, what is driving this automation, I guess, is a really question. We heard a lot about artificial intelligence, and that's a big driver of this automation. But the other piece that I'd like to talk about is also blockchain. Now, what is blockchain? We'll talk about that. what it is, how it works, and then how can tax professionals benefit from these two technologies. So artificial intelligence, you just had a big two discussions on what it is. It's basically machines making decisions once reserved for experienced professionals, right? So an experienced professional, someone that's 20 years in the property tax business, makes these decisions, and they're decisions that are based upon a lot of learning that has happened. Well, artificial intelligence can replace a lot of those decisions going forward, so that's interesting, concerning, maybe something that we should look at leveraging. Whereas blockchain, this is basically securing transactions without the need for an intermediary. And so a trusted intermediary such as an audit firm, a bank, a title company. If I wanted to sell my phone to Bradley, right? Bradley doesn't know me, he just met me, right? Maybe he didn't even meet me. Is he going to trust me that it's a good phone? Am I going to take his money and run with it and not really give him the phone? There's a trusted relationship that occurs between transactions, and that trusted relationship is Amazon fulfillment. I go on Amazon and I order my cookies, whatever, and I can trust that I'm going to get them for the money that I have paid for them. So there's intermediaries that step in the middle and build those trusted relationships. Corporations, governments, banks, title companies, you name it, there's always an intermediary that steps in there and makes those transactions work. If you didn't trust the other person on the other side, you wouldn't make that transaction. So what if we can kind of simplify and remove that need for trust between transactions? And that's what blockchain is. Drilling down a little bit in artificial intelligence, making it specifically to what we are doing today, but essentially you want to determine the problem you want to solve. What are we trying to solve? Attain significant amounts of relevant data, and that's dependent upon the type of technology that you use for artificial intelligence. Some not so much data, some very large amount of data. Have access to a large amount of computing capacity, hire data scientists, and then those data scientists actually spend most of their time cleaning the data, and then what they really love to do is design algorithms, and so once they clean the data, then they can finally design those algorithms around that data, and then you implement it into production. So that's kind of the whole supply chain of how to develop artificial intelligence. We talked about expensive. Obtaining significant amounts of data is expensive to do. Having access to large amount of computing capacity, that's expensive, right? Large data centers. Hire data scientists. Either the top earning people out in the marketplace today are data scientists. So yes, it's expensive, but that is changing because of things like Amazon Web Services, where anybody, such as a startup like crowdREASON, can get access to significant computing capacity, to significant data. Data is being commoditized, and so the cost of data is dropping dramatically. And then hiring data scientists, kind of what we do at crowdREASON is we hire people around the world for a very specific use case. And so it may be that I have a programmer in Ahmedabad, I have a programmer in Victoria, Australia, I have a programmer in Berkeley, programmer in London, and then also 5 programmers in Dallas. But so I can find the right people to develop the applications and kind of in a very small microcosm way of getting things done. These things are changing how to get very expensive problems solved. Some examples of data collection that are, Tesla crowdsources data from its vehicles and drivers. So, how you hold on to that steering wheel and what you do and how your eyes look to the sensors, they capture all of that data for all of their vehicles. And so they're able to improve their autonomous driving through the data that they collect. That's a lot of data if you think about it. I mean, it's terabytes of data. Where Facebook crowdsources user clicks. You click on these clickbaits, or you click on certain ads or whatever on Facebook, and then all of a sudden you start getting a lot of those similar types of data or news feeds that are relevant to what you like to see. So that's how Facebook uses it. And Uber They use it in many different ways, but in this case, they systematically scrape data from other competitors and figured out kind of better ways of picking up people. So there was an example of what is AI, and it's really, there's this big circle of AI. I like Dub's example. Within that, there are things like neural networks or deep learning, and there are also things that are talking about machine learning. And so some of the more complex applications are, H&R Block with Watson, so you put your tax returns in there, it figures out the best way of getting all your deductions. Larry talked about AlphaGo and to how they were able to beat the world champion with AlphaGo. There's actually a movie out on this that this guy was pretty upset that he lost, right? So he's like the world champion, and it's almost broke him because he lost to a computer. But in essence, what happens, there's a lot of complexity that happens in neural networks. It looks a lot like your brain, very synapses of neurons that make decisions and essentially weight what they are receiving to ultimately determine what that output is. We are not focused on the neural networks. We have focused more on the machine learning piece of doing the training. So. And there's reasons for that. Is that, first of all, there's what's called supervised and unsupervised data. Unsupervised data is basically you throw in a bunch of data and let the computer decide what's important, right? As opposed to supervised training is that here is the data set and here is the answers that have been given by trained professionals, right? So you can begin to run those through algorithms to better predict what those answers should be, right? So you throw in a lot of data and you know what the source of truth is for that data, and running through these algorithms, you can get very, very high accuracy if you begin to clean your data and run and develop nice algorithms. And so that's the complexity that's in machine learning. We actually use a random forest technology of using, it's essentially like a decision tree, right? So if this, then that, and then there's certain weights on it. So what is blockchain? The next thing that is interesting in terms of this automation, it's not Bitcoin, which is where everybody goes, right? The conversation tends to devolve into the price of Bitcoin when you talk about blockchain, because that's what's in the news today. It talks about how many Lamborghinis a guy just bought from his winnings in Bitcoin to someone who's lost their money recently because of the price going from 19,000 to this morning at 11,000, right? So a lot of volatility in this cryptocurrency. So Bitcoin was developed by Satoshi Nakamoto in a paper that was published in October of 2008. I think the first Bitcoin transaction was January of 2009 of that year, kind of stemming off of the big bank decline, right? So the 2008 banking related issues around mortgages and everything else, where they had the big collapse. Somebody came out and said, hey, look, here's a better way to do banking, and that we don't have to trust the banks anymore. We can come up with this cryptology way of building a trust without having this intermediary. And oh, by the way, we can also kind of create Bitcoins on top of that. So think of Bitcoins as an application that sits on top of blockchain. So there's the internet, and then there's applications that use the internet, right? So blockchain is akin to the internet, and Bitcoin is akin to applications. Just, I guess, an interesting story about Satoshi Nakamoto is nobody knows who he is. You can't look this guy up. You can't find him. It's a mystery who Satoshi Nakamoto is. And so also interesting enough is that he owns 1 million Bitcoins, which makes him, I think, the 44th richest person in the world from designing this paper in 2008 and actually doing a little bit of his mining of Bitcoin. So, but nobody knows who he is. He's never transacted his Bitcoins, and so very big mystery, right? But aside from Bitcoin and moving that kind of confusion out of the way of what Bitcoin is versus blockchain, the underlying technology has the potential to universally reshape the way business transact in every industry, in nearly every industry globally. And so whether that means that you can transact money or transact goods, electronic goods or physical goods from point A to point B, and that point B could be anywhere in the world. It could be a farmer in Costa Rica when you're buying coffee beans, and he doesn't need a bank for that transaction. My daughter was abroad doing studies in London, fashion design, so she's actually here locally, but she got her purse stolen, right? And so her purse, she was on a train, purse stolen, which means she has no money, she has no credit card, she has nothing. And I got a frantic call and saying, I got nothing, can you send me some money? Well, I said, oh, okay, maybe there's PayPal. And PayPal doesn't work in the United Kingdom, right? So the only way I figured out was like Western Union, crappy service, and 10% of whatever I send her, Western Union was happy to take that money. So if I was able to send her Bitcoins, I could do it instantaneously, and then she'd have to convert it into U.S. dollar, or in that case, pounds, or euros. But in any event, it basically removes the friction that is created between transactions. There's tremendous friction. Even when you're trying to pay someone through your online banking or doing ACH, it goes through all this crazy 1970 computers that transacts the money, and it takes several days to get it done. That should not be economy. That should not be in our economy today. The technology is there today to immediately transact funds, you can sell a house in terms of how to work through all the underlying paperwork, and do you no longer need warranty deeds, all kinds of different things that Bitcoin can solve, or rather blockchain can solve. So how does it work? What is all this big hype about blockchain? And I'll get a little bit of nerdness on me, but and talk about kind of cryptographically how it works. But I just put in the words 7 years ago. Call that a document, call that a file, call it a spreadsheet, call it a video, call it whatever you want to put in there. It's nothing but bits, right? So binary code, essentially. This 7 years ago can be converted into a binary code, ones and zeros, right? It's just a stream of ones and zeros. A video can be converted into binary code, just a bunch of ones and zeros. Taking that binary code, so first of all, it takes whatever it is, converts it into binary code, into its original format, and then provides, in this case, I use a 32-character hash, and a hash is basically an alphanumeric stream of numbers and letters that is unique to that. There's nothing, if I put a lowercase f on 7 years ago, I would get a completely different hash. If I put a period on the end of this sentence, I would get a completely different hash. If I put a space anywhere, I get a completely different hash. So why is that important? Is that I can, and also, I cannot take this hash and then kind of unwind it and say, oh, okay, that's 7 years ago. So there's no way to get back to the original. I can only go one way. So what that means is that I can type 7 years ago exactly in that format, do a hash, and I'd come up with exactly that, right? So that allows me to validate that what I originally put in is exactly what's there. And so you can take this hash and then along with some metadata, which is just kind of related information that you want to add to it, and you can put it on the blockchain. The blockchain is a ledger that says this happened. And so basically it is a truism by saying if this is on blockchain, and let's say I sold this statement 7 years ago to somebody for $1, and we agreed that that was $1 and that's what you're getting, I can publish that hash on the blockchain, and it cements that transaction. And someone says, "Oh no, we didn't do that." It's like, yeah, we did, because it's on the blockchain, right? So it doesn't require a trusted relationship between two parties in order to make a transaction. So normally, Amazon sits in the middle, or a title company sits in the middle if you're transacting houses, or whatever, right? Our government stands in the middle, and it works as that intermediary, trusted intermediary. And so you don't need that in this case. And so billions of dollars can be transacted in this fashion. And you cannot, it's difficult to break that code. So in other words, you can't take that hash and unwind it. It would take an almost infinite amount of time, computing time, in order to do that, in terms of when you look at kind of deeper ways in which it sits on blockchain. Even if you use quantum computing, which is the next generation of computing, if you increase the size of your hash, it just can't be done. So what is blockchain? Blockchain is a set of individual transactions known as blocks. What are blocks? They're cryptographic proofs with other metadata, as I just described. And they're chained with other transactions. And so the impossible way of decrypting that one hash is exponentially greater as you chain together them with other hashes. And I'll talk about how that chain works. But these blockchains make transactions immutable. You cannot change them, right? They are a fact. And so if someone, you think about in today's world, I can create another dollar. I can maybe change the serial code on the dollar, or I can make some fake currency, or I can have a document and I put it through Adobe and I can modify that document and change the transaction price and say, no, this is what you signed. This is what it is. And so there's things that in a normal sense are not safe, right? So, but through a blockchain makes these perfectly safe. And it's published on a public ledger, and it never goes away. And so every transaction that ever occurred on the blockchain, it depends on which blockchain that you're using. There's many of them out there. Bitcoin uses one of them. Ethereum, Bitcoin, Ripple, Factom, on and on and on. These are traditional blockchain methodologies. So they never go away. So they're always out there. And so you can't say, well, I lost the data. In fact, there's transactions that publish on multiple blockchain services, and just to enhance the fact that they're never going to go away. So why isn't everything already on it? Because it would make sense, right? There's high transaction costs. This is ever so more increased because of the cost of Bitcoin, and I'm looking at really how to publish a transaction on the Bitcoin ledger. It's currently around $20 per transaction. So, well, wait a minute. If I sold a piece that 7 years ago for $1, that's going to cost me $20 to prove that it existed, right? So that's a problem. So the cost of the transaction is keeping people from doing it, as well as the amount of transactions that can occur. And I just got an example of Visa. They transact about 56,000 transactions per second. That's in 2016. It's probably double that. I don't know. Whereas Bitcoin can only do 3 to 4 transactions. It's fundamentally capped around 7 transactions per second. And so, wait a minute, there's too many transactions where it doesn't work, where you can solve it. And here is a way in which strategies of which are being used to solve this problem. So we talked about the hash, 7 years ago, gets hashed into this 32 character hash. But what happens if you then say, all right, let's take that transaction and let's compare that where I was going to sell my cell phone to Bradley and also put that in there. And now we have 2 hashes, right? 2 separate hashes. Well, what if I just bring those 2 hashes together, concatenate them, and then hash that? Well, now I've got a hash that manages both those transactions, right? So a proof that both transactions were absolutely positive. Well, I can hash a hash, a hash, a hash, a hash, and I can do that as long as I want. And there are providers that are using what's called Merkle tree approaches to basically anchor that top hash into the blockchain. And so millions of transactions could occur with one hash because of the Merkle tree approach to making this possible. So what that means is the blockchain is infinite in terms of how you can manage transactions. So now, instead of 56,000 transactions per second being kind of unattainable in a traditional sense, it's millions and billions of transactions that can happen per second using the Merkle tree approach to hashing and rehashing that data. And then the cost gets basically down to zero. So now you've solved the transaction time, you've solved the cost associated with that transaction, and now we're sitting with, in 2018, an opportunity to say, wow, now what do we do, right? So we've solved this transaction-related issues. So now how does all this relate to us as property tax professionals or as tax professionals or other professionals in the audience? So I don't know if this will work, but in essence, it goes to a Tableau dashboard, and in that dashboard, it talks about different industries that are out there, right? And then they're broken down, the industries, into various functions that those industries provide. Well, if you click on things like financial services or just simple services industries. So in essence, it identifies specifically what can be automated within kind of our industry, and data processing and data collection are the two absolutely top ones that can be automated, right? So taking that a bit further, what does that mean for us if data processing and data collection can be automated? Well, what are we talking about? So if you think about kind of a day-to-day activity of data collection, where do we get our data, right? Well, it's from the taxing jurisdictions, and a lot of times it comes in a form of a document, right? That document is either a property tax bill, a notice, a blank return that says, hey, fill this out. And so that is kind of data that we get in, but it takes a trained professional to extract that data off, right? So looking at a tax bill, every single tax bill looks to be different, right? I mean, there is in fact 10,000 plus collectors that are out there, and they do whatever they want to do in terms of how they interpret the data. And so it's not a simple, structured, very easy template. And so it's called unstructured data. It's many different classes of how they view the data. So it's unstructured data. That's a very challenging problem. And so 80% to 90% of the data that's out there today is all unstructured. And so if you can't, it's easy to manage structured data, because think of a table in a spreadsheet or a table in a database, you know what it is, right? So whereas just kind of a blob of data, you don't know what it is. And we call it a bag of words, right? So you take a document and you OCR it, and what do you get? You get a bag of words, right? But and how do you then interpret that data? So there are trained decision-making activities that also can be kind of managed through AI, and that is what I classify my assets as, right? So in traditional sense, people in compliance will determine, okay, it is a vehicle, or an F-150, and I'm going to turn that into a vehicle, right? So that's what it's classified as. There's all interpretation that is done throughout the entire fixed asset database in order to decide what is the classification of that asset. That is an easy machine learning part of the activity. Table form selection. Which form should I select? Which depreciation table should I select based upon certain attributes of this classification? That's an easy one. And so what you need to do is have certain data, train from that, and you get to. Then there's, I need to assemble all this data, package it up, and prepare it and send it off to an assessor. That's easy as well. Appeal processing gets to be, if you break everything down into an individual workflow about what you do, much of that can be machine learned. There's things like actually physically going to the assessor or the if you are the assessor, that conversation and negotiation that happens is not something that is necessarily can be automated. You can help fulfill that process through automation, but the ultimate decision making is not necessarily something that can be done as easily by machine learning. And then tax processing and payments. Why aren't all tax bills that come through being automatically processed and paid based upon kind of a machine learning response to that data? I believe they can. So that's a big part of what takes up our time for many professionals is the compliance process, and we're working to automate that. So now blockchain. What is the blockchain in terms of how that could be applied to property tax professionals? So data collection. You think about jurisdictional attributes such as what's their address? Where do I mail this appeal to? Where do I mail this tax bill to make sure that they receive the payment properly? What are the rates? That can be managed in a blockchain database where it's a source of truth, where you know that that's the truth and you don't have to interpret what is the truth. And so jurisdictional rules, whether it's taxable or not in different jurisdictions, the due dates, all these can be kind of locked into a source of truth. All of these activities, specifically around tax bill processing and payments, that's the big one, right? That's the end of the game where you're paying the tax bill. What happens if you mess that up? There's big penalties associated with that. But that's blockchain can solve these solutions of basically human interpretation as well as human error that occurs. And there are human error on both ends. We've seen incorrect printed tax bills, for example. So what's the value proposition for AI and blockchain? There are many different ways to look at this. Significant reduction in operational cost for companies, consultants, assessors, and collectors. All of these data collection and data processing things that occur can be dramatically changed through implementing AI and blockchain into these processes. There's a significant reduction of risk, errors, missed deadlines, zero penalties. If you've got everything locked down into a blockchain source of truth, there will be no errors. There will be no interpretation of a particular answer. For audits, if you want to, taxing jurisdictions say, hey, I want to audit your assets, and audits can be essentially locked down into immutable truth within a blockchain world. And so this is the truth. It's not something I've interpreted as what is kind of the way to do it. It is the truth. And so you can assemble together audit records as they're being worked, so you don't have to come back in time and say, all right, let's try to recreate what we just did. If it's done appropriately, it can be done instantaneously. Now, what do we do with all this, extra work? The 30% or 15% that have now available time to do other things, you can then deploy them into other areas where they're higher cognitive levels, right? So it's like decisions of whether your assessments are correct, right? So, which are essentially where most of the value of the business sits is in that piece of it. So I'm going to pause there. Any questions about any in all of that? I threw out a lot of stuff. Everybody believes it 100%, right?
Hey, Carl, is this an easy or a hard process? That's what Larry was talking about before.
Much of it is easy, yeah. I think as you get into the hard problems, it is kind of those negotiations and physical presence and relationships, and those are the harder problems to solve. Any other questions? Oh, come on, guys. It sounds crazy, right? So it sounds like, wait a minute, you're talking about, you can't do that. You can. And if whatever doubt is in your mind is actually standing in the way of actually this happening. And so, what are your doubts? What's the immediate thinking?
Just curiosity on the security level or
Sure.
the authentication level. When I hear of Bitcoin, and I'm clueless about this stuff, right? So Bitcoin is generated. I hear there's an operator in Wenatchee, Washington, right, that uses a lot of electricity. They're producing so many a day,
Sure.
right? What is that security versus this type of security when you're looking at it as a commodity or a currency versus the general term Bitcoin
Okay.
or blockchain?
So the Bitcoin, let's delve a little bit more into what happens with a Bitcoin. There are people generating a lot of electricity. I heard a comment that says there's more electricity being used up by data miners for Bitcoin than all the Teslas that are being recharged out there, right? So it's a lot of electricity. What is a data miner? A data miner is trying to decode this cryptography. The first one to get it done gets a Bitcoin, right? So, but then everybody that runs the ledger on a blockchain has the same exact data, and so it's a copy of itself. It's not a copy. It's basically everybody has individually created these blocks and submitted them on the blockchain, and everybody has a copy of that ledger. So you can't say, well, I'm going to, and talk about security, I'm not going to get into your computer and like muck things up on your ledger because there's 300,000 other miners that says it's different. And so what happens is your chain gets forked. It's a technical term, and that essentially falls off because it doesn't have kind of plurality of what happens. Plurality means if you're not 50% plus one more, then it's not the truth. And so because of this distributed network of computers and because of the way in which the blockchain is set up, it's perfectly secure, right? So that's the security answer. You had a lot of questions on there, but is that primarily it? Okay. So it's not just one blockchain out there. There's many. I didn't get into really what is valuable is that not only can you like save this hash or hash of a hash of a hash, this Merkle tree, right? But every single individual hash can also have what's called a smart contract. And so I'll get right to you, George. So in that smart contract, if a particular events occur that are established within this transaction, sorry, Christian, if the Patriots win the Super Bowl, and Christian put a lot of money on it and thinking the Eagles are going to do it, then boom, it happens, right? So it's not like, well, I didn't really make that bet, come on, so that's what's called a smart contract. So that smart contract can occur upon events that happen. So that creates even higher value to this blockchain event. So in other words, here's the transaction that everybody's agreed to, and here's the events that haven't occurred yet but will occur. Once they occur, then the money gets released, right? Or the transaction gets instantiated. So, and it can't be changed, right? So once it's done, it's done, and it cannot be undone. So that's, again, maybe some of the security.
I think you answered. I was trying to figure out how does that initial transaction that's embedded in the ledger, how's that validated? You say you've got two parties that agree.
Yes.
How does blockchain account for fraud, abuse, things like that, where Bradley is party one, and then he changes his name to Frank to be party two for some sort of transaction? How's that validated? How that goes to security?
Well, in this case, let's say Bradley has a wallet. Let's call it a Bitcoin wallet, which is nothing but a QR code. You've seen these QR codes. That says, I'm Bradley, right? And I'm going to make this transaction on my phone. So Bradley, don't lose your phone, or don't lose your password, or don't lose your hashed account number, because whoever has that hashed account number can make that transaction, right? So that is basically saying, well, that's Bradley. That's nobody else but Bradley unless Bradley lost his phone. So there is kind of this fluidity about kind of the device or the person making that transaction on their account that has to be true, but someone can get it in. But I mean, it's that level. I mean, you can't, like, the level of security that I've just talked about is not what happened to Target. It's not what happened to J.P. Morgan. It's not what happened to all these people that have been hacked into. Those weren't the problems. People got into, you know, their credit card accounts and did all kinds of things. But that you just, because they're hashed and you don't know who's who, it's a certain sense of security that's not available in like Equifax. You know, who knew that your credit rating was hacked? But does that help? Yeah. Okay. I'll talk a little bit about one of the applications I won't spend time on, but basically this is an application called Metatasker, and it ingests property tax documents, right? So property tax documents come in, and magically all the data is structured and gets automatically processed in your application. So the individuals necessary to actually extract that data can spend time doing other things, right? And so it's a process where it's 99.9% accurate in terms of the extraction of the data. And then, you know, here's an example of a client that has, I think we over 70,000 documents in there. We track kind of the process over time, what type of documents come in, whether they're real estate bills or personal property bills or notices or blank returns or whatever. But that's an example of, and I guess another thing that we hadn't talked about, but that's actually becoming more and more common in these conferences that you hear, is called robotic process automation, right? So people may ask, what is RPA? If you haven't heard it before, you will hear it in the future very soon. It is a subset of AI. It's really, basically, it's logic, right? So think of it as being, whatever actions that I click on my computer, and I'm making those decisions based upon this click here, that click there, all of that can be automated. So all the legacy applications that are out there, you can put RPA on top of a legacy application, and you can effectively do what a user could do in a very, very rapid fashion. So you find yourself going to Oracle and pulling out fixed asset data and doing some things with it, and then all of a sudden, you structure it and format it and put it out. All of those activities are part of RPA, right? So you can create the code that sits on top of those applications and do all that. That's RPA. That's a kind of the beginning piece of artificial intelligence, and so you can either put that on top of legacy applications, or you can build that functionality inside of an application. And so Metatasker has that functionality built into the application as opposed to you having to create something on top of it. The other thing that Metatasker does, it talked about the bag of words, right? So it takes a document, it OCRs it, and you get basically a bag of words. And then you also know, based upon a very structured process of how we get data, what is the truth of those words, and then you can run algorithms to determine, if you got another bag of words, what is it? What's the answer to that? And it's more than just the bag of words. It's also using computer vision. An example of computer vision is Amazon just opened a store in Seattle where you walk in, you pick up stuff, and you walk out, right? You don't have to stop at the cashier because they know exactly what you got. They're using computer vision algorithms to look at what you're getting. You have to download an app before you walk in the door, but I don't know if they lock the door if you can't get in, but you download, they do lock it? Okay, good, they should. So you download this app, your credit card information's on there, walk in, get what you want, walk out, and you're done. So that's computer vision. And so you can use computer vision on things like physical structures of scans of documents to say, oh, okay, well, this tax amount's normally down here, but it's normally down here for a particular jurisdiction and a particular tax year, right? Because the following year they put it up over here, right? So it's if you use kind of the traditional ways of kind of templating a document, well, that's only good for that jurisdiction for that year, Next year they change. And so templating doesn't work for unstructured data. So unstructured data, you have to kind of automatically understand the data in order to extract it. So in this case, we extract data off these documents and import them into the systems. The challenge here was, one, we use machine learnings because the typical machine learning challenge, I should say, is that you have 5, 10, maybe 20 classes. We talked about Amazon machine learning approach. I think they max out at 50 classes, and you can't have any more classes. What is a class? A class is think of a tax bill. A tax bill is a jurisdiction. You know, whereas a tax bill is the year. So I talked about what changes that template every year. It's a year in its tax jurisdiction, right? That jurisdiction is either a collector or an assessor, right? So it's, as you think about it, there's 10,000 assessors and there's 10,000 collectors at a minimum. So you can't run traditional machine learning technologies using a limited, even in Amazon's great machine learning 50. So you have to do some various things. The other nice thing about machine learning is that you have to have a reasonable size amount of ground truth. It doesn't take a lot. It doesn't take like big data. And so that fit our need. The other thing about, not only do you have, in property tax, do you have many, many classes, but these classes change constantly, right, from one year to the next, even within the year. And then you have a variable size of ground truth results. So you don't know, maybe your clients only have a few accounts here and a lot of accounts here, and so it's varying amounts of ground truth. What is ground truth? Ground truth is basically an answer that a experienced professional says that's the right answer, right? So, so what we did is we cleaned our data via, I said a lot of the work within AI is cleaning your data. So you have to have good data goes in, because that's what you're going to base your truth off of. We did that based on an isolated data sets of our trained crowd. 20,000 people around the world helped us create the machine learning ground truth data. And then we fingerprinted each and every document that comes in. It's similar to, there's different ways of doing it. You can fingerprint by squashing down the image to where all of a sudden it's just kind of a general look and feel. It's kind of like that Tesla picture or that photograph of a car, Audi RX, right? If you squash it down so small, it kind of all looks the same, and you don't necessarily see the intricate details, but you know that there's kind of a seal up here, you know there's kind of somewhat of a structure. That's called a p-hash. You can do that, or you can actually do kind of machine learning around the XML data to auto-template the data. So that's what you do. And then you've got these volumes of data that comes in, and you need instantaneous machine learning in order to leverage off of that first document that came in. You want it to apply to the next 1,000 documents, because that's what happens that particular year. We use Spark clusters and distributed computing to actually go out there and update that machine learning on a day-to-day basis. And tiers of classification. We broke the classification into multiple tiers. We developed our ML random forest technology ground up. There was nothing out there that was available to use that would work, and that's essentially how we built that application. So the results are classify 98% of the documents, document type, jurisdiction, assessor, collector, put in something. I don't care what it is. I will tell you what it is. We'll tell you who it came from and what is the jurisdiction specifically. That allows us to populate a source of truth. Now we have a source of truth. You can blockchain that source of truth, knowing that that data came from a document and that is the truth, right? So it's not based on an interpretation of what somebody says. The extraction, 60 to 70% of the data is automatically machine learned and extracted. The other 30 to 40% we send to the crowd. That helps us continually learn on things that it didn't know before, right? So, and then we refeed that back in, retrain it, and that gives us 99% plus accuracy on all of our documentation. So what that means is that the grunt work is out of the way, and now you can focus on the value-added work. And then careers elevate, overtime's lower, and then You get happy people. So that's I think the benefits of this type of technology. Any questions?
Did I understand you say you're already using blockchain in here?
It's in the development mode right now, but yes, we're working with a company on blockchain to specifically do things around tax bills and things around data, and locking down a source of truth for data and locking down a source of truth for tax bills, because you don't want to make an error on tax bills. Yes, sir.
How adaptive are these systems and cost effective? Well, you don't want to be caught up in the 4G, 5G transition.
Sure. That's a great question, and it's something we deal with daily. Our belief and our mantra is that data collection and processing should ultimately cost the cost of electricity, right? And so, well, what stands in the way of it costing the cost of electricity to process this data, or the whole lot of things, right? So we work on essentially each and every one of those areas that block us from that answer, and we work on the big ones first, and then we get into the smaller ones. So that basically allows us to first of all offer the service at a very low cost, but then also continually improve. I mean, our cost improvements are 50% over just that 1 year, right? This past year, we want to continually get that cost down where it's cost of electricity, and then who knows, when solar gives us free electricity, then it's all free, right? So that's the way in which we continually evolve with the technology. We use the thing about using AI and an electronic approach to doing things is that you're not subject to physical limitations, right? So if you move it to electronic nature, then all of a sudden you can ride the wave of the exponential curve. And so that's how we're keeping on the exponential curve, is that we've transitioned all of this physical stuff into an electronic space of which we can continue to leverage off of new technologies. Yes?
Do you consider getting tax jurisdictions and tax administrators on board? So instead of starting with a tax bill, can you offer something to them that they can input into the blockchain?
Yes, that's the end game, right? So in essence, they issue you information electronically, and it's on the blockchain, and you transact that, whether it's paying a tax bill, whether it's appealing your return, or whether it's filing your return. Blockchains talk to blockchains, and so that's the end game. You kind of have to work with what you got right now, and so what you got right now is these physical documents floating around, and if you think about electronic filing for jurisdictions, even electronic payment for property tax, it's a third world out there, right? So it's not going to happen for a while, but it's going to happen. But we're just trying to bridge that time period.
I've got one quick question.
Okay.
What happens when the courthouse burns down regarding blockchain?
So you don't need a courthouse in blockchain.
Well, this is an analogy, though.
What happens, well, the thing about, it's a good analogy or a good question, because it basically says you're dependent upon that one infrastructure, right? Maybe all the warranty deeds and liens that are in that county clerk's office. What happens when it burns down? It's lost, right? We're in a blockchain situation because of this distributed network where it's distributed across hundreds of thousands of different computers. If a computer drive blows up, it doesn't matter, right? So the distributed network improves that dramatically.
Okay, now is there any ways where the different versions of the courthouse, now we have 1,000 courthouses, say, what happens if the courthouses disagree?
That's the blockchain where if more than 50% plus one says something, that is the truth. If the others don't agree, then that fork falls away, and it's no longer the truth. And everything starts with this. And so there's forks that fall away all the time because they don't match up to the other ledgers. And so it's the epitome of, we look at our tax bills 3 times to make sure they're right? No, it's not. Think about it 300,000 times. So it allows for basically immutable truth, because it's the probability of it, even through nuclear war, even through, natural disasters, it's not going to impact it.
Okay, so somewhere the right thing will be there, the right hash.
Yes.
Okay.
Right.
Okay, with that, let's take a break. Let's start again. Yes, well, thank you very much.